Remember I told you how we don't have a new function type in Java that all these lambda expressions are typed as. We have reused the interface type that's been available in Java for all along. There are actually several reasons why the Java language designers decided to use an interface as a type for lambdas instead of creating a new function type. The most important reason, though, is backward compatibility. Think about what needs to happen if they had chosen to create a new type called the lambda type or the function type. What would have happened is you could have used the lambda type only in other code which also use the same lambda type. For example, let's say you want to use a library and pass a lambda expression to that library. Well, if there was a new function type, you would have had to rewrite the library to accept this new function type as well. Now, the advantage of using an interface is we can use lambdas in place of all those anonymous inner classes and all the other method signatures which accept the interface. You don't have to rewrite them for the new function type. So this is a huge advantage when it comes to backward compatibility. Let's take the example of a thread and a runnable. Remember that there is a runnable interface which has a method called run, and in order to create a new thread, you would have to create a new instance of runnable and use that instance in order to create a new thread. Well, guess what? Since runnable is an interface which has just one method, it works just as well with a lambda. You can use a lambda in order to create a new runnable. Again, remember though that whenever you're doing something like this, it must be an interface with only one abstract method, and runnable is a perfect candidate for that. So in this tutorial, I'm going to demonstrate how you can use a lambda to take the place of an instance of runnable. I'm going to create a new class called runnable example, and we take in a main method. We need a main method here, so get rid of this comment. Now what I want to do is create a new thread and pass to it an instance of runnable. For example, I could say thread my thread equals a new thread. Now this needs to take in a new instance of runnable. I could of course create a new class that implements the runnable interface and then create an instance of this here, but I'm going to create an anonymous inner class. I'm going to say new runnable, and now since runnable is an interface, I just cannot say new runnable and be done with it. I need to provide that implementation here, because if I just do a mouse over here, it says I haven't implemented the method. So add unimplemented methods. Ideally there should be just one, which is the run. So I'm going to implement this. I'm going to have a simple system.out printed inside runnable. So this is a classic example of an anonymous inner class. I need a new instance of runnable, and the runnable just has one method. So rather than go create a new class, create a separate file for it, and then create an instance, I'm just doing an anonymous inner class. I just need this once, and I'm not going to do this again. So I can run this. I can say my thread dot run. Let's execute this. And here you see, you get the message printed inside runnable. So I was able to spawn a new thread, and then I was able to execute this piece of logic. This is a classic case where you can use a lambda. Rather than create an anonymous inner class, we can create a lambda. And the thread constructor doesn't know any better. We can create a lambda which has the same signature as the public void run, which is the one method of the runnable interface. All that the thread expects is an instance of runnable. We are going to sneak in a lambda, and since a lambda behaves like the interface that it expects, thread doesn't know any better, it's going to execute it. So let's demonstrate that. I'm going to create a new thread, my lambda thread, which is going to be a new thread again, but now rather than create, let me give this a type, sorry. Now rather than create an inline anonymous inner class, I'm going to create an inline lambda. So I'm going to say this is a lambda expression that doesn't take in any arguments. You see, run doesn't take in any arguments. I am just going to print something to the console even here. I'm going to call this lambda runnable. Okay, this is all I need to do. rather than do all this boilerplate code, I just create this simple inline lambda right here. And now I can do a my lambda thread dot run. And this is still going to work just like this, and the thread class doesn't know any better. Remember though that this thread class has been implemented way before Java 8. Did the Java 8 developers go in and fix it so that it works with lambdas? Well, no, they didn't have to, because a lambda pretty much behaves like an instance of what it's trying to match as an interface. So this lambda is pretty much indistinguishable from an implementation of a runnable that we have over here. So the thread class doesn't know any better. So this is the magic of having the interface mechanism for declaring lambdas. You get this huge backward compatibility. And all the old APIs that we have come to know and love in Java are still accessible, but now with lambdas. Again, the only constraint is the interface that those APIs expect has to be something that has only one abstract method. These interfaces are what are called functional interfaces. I'll talk about that in the next tutorial.